Assalamualaikum. We are from Group 4 and we will be presenting about wastewater treatment of dairy industry. My name is Mohd Hilman and I will explain about the introduction part. Dairy industry conducted a process to transform raw milk into favorable food products such as sour milk, yogurt, cheese and others. This industry has been developed rapidly due to the increases of demand of the product. The development of the industry caused the growth of production for the last decade, which at least by 2.8% growth per annum. The operation done in this industry to produce the product includes homogenization, standardization, clarification, and pasteurization. Drying and condensing process also been done to remove the liquid content of the product. This industry does discharge wastewater from three sources, which the minority of it come from the production process during starting, equilibrating, stopping, and raising the equipment. Meanwhile, the majority of the wastewater was produced during cleaning operation before starting new batch or change of the product. There are three sources of wastewater from this industry that are processing wastewater, cleaning wastewater, and sanitary wastewater. From these three sources, only processing and cleaning wastewater will be treated on the treatment plant, meanwhile the sanitary wastewater will be flowed directly to the sewer. Processing wastewater usually formed during cooling process of milk as well as condensate or evaporation of milk and whey. This effluent consists of small volatile substances, but however it can be reused or discharged with the stormwater right after minimal treatment done. Next, cleaning wastewater comes from washing the equipment involved during the production phase. 90% of organic solid in the effluent comes directly from it and manufacturing residue. Lastly, the sanitary wastewater comes from lavatories and toilet. It has same composition to municipal wastewater and generally being piped directly to the sewage wood. The characteristic of wastewater from the dairy industry is normally in white in color and has unpleasant odor and turbid character. The component contribute largely to increase of biological oxygen demand (BODs) and chemical oxygen demand (COD). The wastewater usually slightly alkaline in nature and in high temperature compared to the municipal wastewater. Fine cut inches waste contribute to the suspended content matter of the wastewater. The effluent also contain high dissolved oxygen (DO), dissolved solid, suspended solid, chlorides, sulfide, oil and grease. That will be treated along the treatment process. This wastewater also consists of mixed constituents such as casein, inorganic salts, detergent and sanitizers. And lastly, during cleaning process with caustic soda will produce sodium content in the wastewater. Discharging untreated wastewater from dairy production in the industry may cause a very harmful effect to the environment. First, untreated effluent can cause 60 to 80 times more polluting than domestic sewage. Dairy industry generate high volume effluent that is 2.5 liter per liter of milk processed. The wastewater able to deplete DO level of the receiving stream and releasing strong foul odors. Receiving water could become breeding place for flies and mosquitoes carrying dangerous diseases to the human. This wastewater also toxic to certain varieties of fish and algae. Algae growth and bacteria will consume oxygen in the water and suffocate the rivers, leading to disappearance of fish in the river. There is certain legal requirement need to be followed by the industry in order to discharge it before discharge it to the environment. According to the Environment Quality Act 1974, every effluent discharged from the industrial sector must follow the fifth schedule. The schedule has two standards according to the position of discharge point. There is standard A and standard B. Standard A is used when the discharge point be located before drinking water intake point. Meanwhile, standard B is used if the discharge point located after the drinking water intake point. The standard A has lower concentrated pollutant level to ensure that the water is less contaminated and reduce the treatment cost for drinking water later. The figure shows the flow process of wastewater treatment of dairy production industry. The first, the raw wastewater will enter pre-treatment process. There is preliminary treatment, equalization, and solid removal depth. In this process, solid particle will be removed from the wastewater. Next, the water will enter the biological process, where the water is further treatment to reduce the organic and organic compound in the wastewater before being discharged to the sewer or water bodies.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zuhairi bin Azman with matrix number BNN40703. So for the general pre-treatment, the pre-treatment process usually start with an evaluation of the water and assessment of the discharge circumstance. If we assume a generic wastewater and the specification of the discharge permit is obtainable, then pre-treatment likely will follow a basic course of treatment. The goal of treatment is to remove waste solid in the water, including suspended and dissolved solid, metal, and synthetic chemical. Many industry applications create microscopic materials small enough that they can get through mechanical filtration means. However, with appropriate chemical treatment, the plant can remove ion and smaller dissolved solid from the water, as well as the suspended solid. The top three types of chemical treatment for wastewater involve pH adjuster, coagulant, and flocculant. So for the dairy industry, wastewater contains suspended and dissolved solid, soluble and trace organic nutrient, fats, chloride, sulfate, lactose, and they are characterized by high chemical oxygen demand (COD) and biological oxygen demand (BOD). Pre-treatment mainly consists of removing unwanted components which could disturb the successfully functioning of the treatment plant. On the dairy plant, the process of pre-treatment consists of screening and flotation. In the pre-treatment of dairy plant, first is by screening. Screening is an operation involving the removal of coarse waste with help of grating and screen. It is to eliminate large particles that may cause damage to pump and blocking of downstream for purpose of avoiding further increase in COD content due to solid solubilization. Physical screening of dairy wastewater should occur as fast as possible. Usually, the screening process is divided into two stages, which is coarse screening and fine screening. Coarse screening is to remove solid of nominal size 20 mm and above. Fine screening is to remove solid of nominal size 0.25 mm and above. Manually clean screen require little or no equipment maintenance and provide a good alternative for smaller plant with few screening. Mechanically clean screen tend to have lower labor cost than manual clean screen and offer the advantages of improved flow condition and screening capture over manually clean screen. After the screening process, it will undergo the flotation process, particularly dissolved air flotation (DAF). Has become the most frequently used process for the removal of fat and grease. In this process, air is dissolved in water under pressure, and then the supersaturated air water mixture is injected into the flotation tank. The air comes out of solution in the form of micro bubble, which attach themselves to suspended matter, including fat and grease, which then float to the surface. The floating material form a scum on the surface of the tank is removed intermittently by a mechanically skimmer.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Sufi Huzaimi bin Muhammad Fauzi. Now I will explain about the sequencing batch reactor (SBR). A sequencing batch reactor is a single tank fill and draw system that aerates, settles, withdraws effluents, and recycles solid. A single batch reactor can be used for equalization, aeration, and clarification. Therefore, elimination of clarifier and other equipment can be used to save the total cost. There are 5 steps that are usually implemented in this SBR, which are fill, react, settle, draw, and idle. Wastewater is mixed without aeration process in order to provide metabolism of the fermentable components while the tank is filled. The following stage is aeration process that contributes to the oxidation and biomass formation processes. Afterwards, sludge is settled and the treated wastewater is separated to finalize the cycle. SBR depends strongly on the site operator to regulate the duration of each stage to reflect fluctuation in effluent composition. Now, I will explain about the mechanism of the SBR. The process in the SBR involves the following 5 stages. First, fill. During fill, the influent wastewater is added to the biomass that was left in the tank from the previous cycle. It may be either the raw wastewater or the primary effluent. The fill mode can be kept either aerated or non-aerated depending upon the wastewater characteristic. The length of the fill period depends on the number of tanks, volume of the SBRs, and the flow rate of the effluent. Usually, the period lasts for 25% of the full cycle time. The change in the length of fill could alter productivity of the SBR process during optimization. Second, react. During react, wastewater flow to the tank is restricted while aeration and mixing continuous. Reaction for substrate removal initiate during fill are completed during react. The time dedicated to react can exceed 50% of total cycle time. The treatment is controlled by air, either on or off, to produce anaerobic, anosmic, or aerobic conditions. Controlling the time of mixing and aeration produce the degree of treatment required. The on-off cycling of air and mixers provide nitrification, denitrification, and phosphorus removal. Thirdly, settle. During this phase, the entire aeration tank acts as a clarifier without any inflow or outflow. Quiescence condition develop give rise to the better solid separation than that of conventional clarifiers. The settle period lasts between 0.5 and 1.5 hours and prevent the solid blanket from floating due to the gas build-up. Fourth, draw, which is decant. After the settle phase, the clarified supernatant is discharged from the reactor as effluent. The withdrawal mechanism should be designed and operated in a manner that prevents floating material to be discharged. Excess waste activated sludge is also removed. The time dedicated to draw can range from 5 to 30% of the total cycle time, with 45 minutes being a typical draw period. Fifth, and lastly, idle. The period between draw and fill is termed as idle. This phase is generally required when several SBRs are in operation. In a multi-tank system, its purpose is to complete the fill cycle before switching to another unit. Now, I will explain about the advantages and disadvantages of the SBR. As we can see here, there have a lot of advantages compared to disadvantages. That's why this SBR is frequently used recent technologies in treating dairy product wastewater. For the advantages, first, cycles modifying is simple, low footprint, cheaper or cost effective, low flow application, wider wastewater strength variation, efficiency of removal is higher in terms of BOD, COD, pH, total solid suspended, and total solid. Capable of achieving nitrification, denitrification, and phosphorus removal. Wide operation flexibility, minimal sludge bulking, which is sludge bulking is most common solid settling problem in wastewater treatment plants, which is caused by the excessive growth of filamentous bacteria extending outside the flocks, resulting in decreasing the wastewater treatment efficiency and deteriorating the water quality in the effluent. Minor operation and maintenance issues, and lastly, may be operated remotely. Now, I will explain about the disadvantages. High energy consumption, difficult to adjust cycle times for small communities, and lastly, frequent sludge disposal. And that's all from me. Thank you.
Next, I will explain about the sludge treatment on the dairy plant. There are only two processes conducted on the sludge treatment pipe. There is thickening and dewatering. Thickening is the increased sludge concentration to improve the efficiency of further sludge treatment process. As the solid concentration increases, the volume is correspondingly decreased. However, the sludge is still behave like a liquid. Gravitational concept is used in the thickening process, where to separate solid and liquid, where the solid will move to the surface of the tank, while the liquid is continuously being moved out of the tank. The slush solid will settle down in the blanket and remove from the bottom of the tank right after the process have been done. And next is dewatering process. Dewatering process is to concentrate the slush up to 35 to 40 volume percent to reduce the slush volume significantly before discharge. The slush is being filtered, pressed to extract the liquid compound, forming an excellent cake dryness. Removing the liquid from the slush helps reducing the volume of the slush, hence reducing the slush disposal cost. The water extracted from the process can be reused for other operational costs. So, in conclusion, the industry has produced food from raw milk. Next, the most of the wastewater produced in the industry come from cleaning operation due to the process residue that being cleaned from the tank are highly polluted. The wastewater from dairy industry come from three sources that are processing, cleaning, and sanitary wastewater. Wastewater produced in the industry has high temperature and slightly alkaline. The wastewater also has high BODs and COD. The biological treatment used is SBR, in which will conduct the aeration process for oxidation and biomass forming process. And lastly, the sludge will be treated before being dumped on the landfill for to give a safety and more sustainable process to the environment. Thank you. That's all from us. Thank you.